Hey everybody, welcome back. My name is Average, and today we are going to be doing part 4 of the ongoing series on this channel called Python for Beginners. If this is the first time you are watching one of these videos, I highly recommend checking out the beginning of this playlist, and I'll leave a link for that in the info card in the top right. Now guys, today we are going to be looking at a few things. Nothing too crazy today, but we are going to be enhancing our knowledge of strings. Now, there's a lot we can do with strings, and for a recap, a string is a data type which includes text content. So, for example, like this. Anything inside of quotes, whether it be double or single quotes, is a string. Now, we can have string literals, and that would be something like this. So if we were to print this, we'd be printing a string literal. This would be just printing a variable of type string. Now, I also want to quickly tell you guys about literals in Python. They have a bit of an interesting behavior. Literal strings are actually completely ignored when they're typed outside of a declaration or when they're not being passed in as a parameter or used somewhere in the code. So for example, I could technically use this while it's not completely intended in the language. I could use this as a multi-line comment or as just as a comment itself. So I can say, and if I run this program, it'll function exactly as you would expect it to with just text content. There's no errors or anything. We can also do a multi-line comment by using 3 double quotes such as this. And this kind of just gives us the ability to make a multi-line comment. Again, it will run exactly as if this didn't even exist. Going back on this, literal strings such as this not used in code are completely ignored. We can also create multi-line variables by doing a similar thing. So we can say, hello, what's up? It's me. And if I were to execute our file, we get hello, what's up, it's me, just like so. So that's how you can do multi-line literal strings. And you can even assign it to variables as well. And each line will actually be treated as a new line. You don't need to do \n, which if you didn't know is a special character type which we can use to signify to the interpreter that we are trying to write a new line. So if I were to do hello \n, it's me, as you can see, \n is highlighted differently, and this means it's being recognized as a special character, and we will get a separation between hello and it's me in 2 different lines. So we are going to be half introducing a new concept in this video, and that is arrays. Now, what is an array? An array is essentially a data type that functions like a collection of things. For example, we can have 1, 2, 3, and this will be a collection of integer values 1, 2, and 3. We can actually access these by referring to their index. So by using r, referencing the variable name, and then we use these square brackets, and we can put a number inside of here. So 0 is the 0th index, which would reference this. The way that arrays work is they start from 0. So this would be 0, this would be 1, and this would be 2. These indexes are essentially just positions that tell the interpreter what we're talking about. So 0 would be 1. 1, if I put that in here, would be 2, and 2 would be 3. It might be a bit less confusing if we use completely random numbers. So here we go. I got some completely random numbers, and in this case, the element at index 0 would be 96. So if I did this, we'd get 96 printed to the console. If I did 1, we'd get 42 printed to the console, and if I did 2, we'd get 128. So basically, the thing about arrays is you have to remember that it starts from 0, not 1. 1 will actually be the second element in your array. Now, why are we talking about arrays in the first place? Well, essentially a string, so we'll just call this string demo, and we'll just say average is our string. Strings in Python can actually be used straight up just as arrays, and it's similar in a lot of other languages as well. So if I were to do a equals demo, and then inside of these square brackets I put 0, we would be referencing the very first character of our string, which is a capital A. And now if I print that, we will get a capital A like so. Same thing goes if I put 1, we will get a V. If I put 2, we'll get the E, which is the third element in the array, and so on and so on. There are 7 letters inside of average, so what would happen if I tried to access the 8th element of the array or the 7th index? As you can see, we get an error that says string index out of range. So you do have to be careful that you are not accessing memory that doesn't exist. If I wanted to access the last element of the array and I didn't feel like counting all the way up, I could use -1. And what this does is it goes from the end of the array and it counts up. So this would be 1, 2, 3, 4, 5, 6, 7. If I did -7, it really would be the first letter, which is A. Same thing goes if I type in -8, we will also get a error when running the code because we are accessing something that is out of bounds of our array. Now, since these are arrays, we can actually get what's called the length of an array by using this new function called len. By itself does nothing, and as you can see, it will say len takes exactly 1 argument, and there's 0 given. One nice thing about Visual Studio Code or any IDE that you're going to be working on really will have this feature where if you hover over a function you don't know what it does, it will give you a brief understanding of what it does. So this one returns the number of items in a container. And as we know, strings are arrays, which are containers. So all we need to do is call len like this, and we need to pass in an object inside, and we get this is the return type, which is going to be an int. So if I put demo in here, we should get 7. And we do. And this represents the amount of characters that are in our array. If we want to get the max index, we would do len demo -1, and now we get 6. So this is the maximum index that we'd be able to access without causing interpreter issues. So if we wanted to say, detect if rage was included in a string, we could do if rage in demo, and if this is true, which it will be for the string average, we can print rage found. Now, when we run this code, we should get rage found. Now, what happens if we just turn this into average? We spell average wrong. We get nothing because rage was not found. So this is a way we can detect if there is a set of characters in a specific order within our string. This is technically just a Boolean expression. If we were to say is rage, we could do rage in demo, and this would function the same way. So we could do is rage. And this essentially just returns true. So I could use this anywhere. I could also print the value of this Boolean and it will say true. If I change average and misspell it, it will say false because rage was not found. Oh, sorry, it won't say anything because this doesn't get triggered. We can do a very similar thing as well. We can say if rage is not in demo, and this will essentially just tell us if rage is not found. Rage is not found. So this is basically checking if a substring of a string is not found. So in this case, since I've removed the R, if we run this, we'll say rage is not found. If I put the R back, we will get nothing, no output at all. So the next thing we are going to be looking at are called slices. Now, slices are pieces of the strings or other kind of elements that we can actually kind of slice off. So let's say we want to slice off rage right here. So we would want the 4th element to start at or the 3rd index. And then we use a colon to specify that this is going to be a slice. So we start at index 3, and we are going to end at a non-inclusive index, which means we are not going to be including this, and we can say 7 because we are not going to be including the 7. We want to go to the very end. And if we were to print this, we should be able to get, as you can see, rage in the console. We can also just do 3 colon and specify that we want to get the very end. We don't want it to stop. We want it to start at 3 and just continue on and on. Now, if we want to reverse this, we could do colon and 3. And basically what this will do is it will get every letter up until the 3rd index, not including the 3rd index. So what we should get here is actually av. And we do. Obviously, we can tell it to start at a certain letter as well. Just like this, so 2 and 3, and we would get the letter E, as this is the 2nd index, and we want to stop at the 3rd, which would be this. In the last episode, we also looked at 2 other functions, .upper and .lower. Now, what these do are pretty simple. They literally just convert the entire string to use either uppercase or lowercase respectively. So when we print these, we will get average in all uppercase and average in all lowercase. Let's say our string has a bunch of white space in it. So there's just a ton of spaces before and after. Not really sure why. I don't know. It's just like this. But we want it to just be the individual text itself. We don't want any of these spaces. We just want to get this. How do we do that? Well, we can do it very simply by using demo.strip. This is another function that will take the string and it'll take everything inside white space before and after. So if we print this, we will simply just get average, as you can see. So this is pretty useful if your text has a bunch of random spaces. Let's say you were getting user input and for some reason they typed in a bunch of spaces at the beginning and all you really want is this. Now we can also replace substrings with other strings. So if we were to use a function demo.replace, we can tell it to replace a substring. So we'll say rage with another substring and we'll say calm. So we should now get avcalm because we are replacing rage with calm. So as you can see, there we go. It also works with individual letters as well. So if we wanted to replace A with an E, we could do that and we can get average. Now, the next thing we are going to look at involves arrays. Let's say we have a function that has a bunch of names. So what if we wanted to extract every name from here and store them in an array of our own? So we wanted it to look like this. Because if it looked like this, we could specify exactly which name we want. So let's say we want to use name 0, which would be the first element, average. And if we print that, we'll get average. But right now, we can't just do demo 0 because if we did demo 0, we would simply just get the first letter, which is average. So how are we going to turn this into a names array? Well, we can do that pretty easily by declaring a new variable, typing in demo, and using another function called split. Now, whatever is typed inside of here, so if we do a space, we'll split our string into an array and use this character or string or whatever as the kind of delimiter. So imagine if these were commas instead, right? You could easily by yourself tell which words are separated by what. So we can tell the compiler what to separate each string with, which in this case would be a comma. And now if we print name 0, we should get average. If we want to understand what the names array will look like, we can print that. So as you can see, average is one of them, John is one of them, Tony, Ella, and Rick. And it does not include the delimiter. Despite it kind of looking like it, this is just to separate elements within an array. Each element of this array will be contained inside of these quotations. Obviously, we looked at concatenation a little bit ago, but I do want to go over it again. Let's say we have two strings and we want to join them together. Well, if we print each of them like this, they will be on different lines. We can also do this where we put A and B, and inside of the print function, this should actually give us hello world. What if we wanted to create a C, however, and we wanted to use A and B? Well, we could do that like so, but as you can see, this gives us a different type of object, and this is what's called a tuple. Not exactly what we want printed. Well, we can use A plus B, and this will append or concatenate strings together. So when we print it, we'll get hello world. As you can see, there's still the issue of no space in between, and we can do this by appending a new string or a string literal, which we will just add as a space. And now when we print this, we get hello world. Pretty simple. Now, there is an even simpler way of doing this, and it's by using an F at the beginning of any string literal. F tells the interpreter that we want to format this string, and anything inside of curly braces will be a reference to a variable. So A in this case will be a reference to hello. And if we do another one with B, we can get hello world. So these are essentially placeholders, but only when this F letter is present directly before a string literal. So if I were just to do this and we printed C, we would get it literally. Now, if I were to put an F here, we are no longer getting the literal sense of it, but we are getting references to variables. Obviously, I can still put whatever kind of text I want in here, and it'll work. Literally, just inside of curly braces, it will not. And what if I wanted curly braces to work? Well, I could just simply do 2 of them. And as you can see, nesting them will return the value inside. Now, that's pretty much everything that I'm going to be showing you for today's video, guys. I hope you enjoyed, and if you did, please leave a like, comment, and subscribe, and stay tuned for the next one. Thank you very much.